morning, Wafaey. How are you?
Good afternoon.
Good. Can you hear me?
Yes, I can hear you well.
Another one. Praise Jesus. How are you guys doing? It's getting cold here. I have to wear long sleeve stuff.
We have a heat wave coming through the Netherlands. It's been quite warm the past week or so.
Yeah, well, I heard in France last week it was like late 30s, 38, 39. I don't know how hot was it in Netherlands.
Yeah, in the south of France it was. And the Netherlands was around 30, max 35 degrees, like yesterday. But as a result, now it's raining and it will be cooling down in the upcoming days. So next week we have got around 20, 25 degrees.
So for the listeners who aren't familiar, you are Qorox in New Zealand who's purchased a CyBe printer from Barry at CyBe. And today we're going to talk a little bit about your experience with the printer you purchased, what you've been printing, some things you may look to print in the future. So far, how has your experience been with your printer?
It's been an exciting journey. It's been a long time coming, I feel, because initially we started the conversation in 2018, and I tried, before talking to Barry, I tried to talk to him to explore what's on the market. And by far, CyBe were the easiest one to communicate with and to work with. And this made me start to seriously thinking about partnership with them. And in 2018, I visited the facility and worked, and we had around 4 days together, talked about business plans and the technology and what we expect from each other as partners. And it was it's very insightful, and it was a beginning of a very good relationship. And since then, I had to work on my end to see how we can get the system to be certified and tested in New Zealand. And after that, we procured the robot that was due to arrive middle of May last year, but because of lockdowns and COVIDs and travel restrictions, there were some delays, and they were out of anyone's control. It's unforeseen, as you can imagine, what's happened everywhere in the world. And robot arrived end of October, and CyBe training team, including Barry and two of the most experienced guys he has, Kevin and Mark, were kind enough to spend 2 weeks in quarantine in New Zealand. And then after that, we spent 2 weeks together. They trained us on the system. We got really familiar with it. We were able to print with it, and we did 2 public demonstrations, and they were advertised and covered in the newspaper. And then slowly we've been building momentum since then, and we're starting to have some decent projects in the pipeline, and it's been quite exciting.
I want to ask about your team and the training process, but before that, can you describe what it was like getting the machine certified and tested in New Zealand?
You cannot certify the machine by itself, but you certify the structural elements that you produce. And it's in New Zealand, for some reason, we have a very unique and awkward building standard because of the seismic requirements, and New Zealand's a little bit disjointed from the rest of the world when it comes to building standards. Like, you have the Eurocode, pretty much covers the whole of Europe. The UK is very similar to it. It's not far apart. The United States, you have the ATSM, and Canada and Mexico and most of America's effectively copy it or have their slightly version of it. But in New Zealand, for some reason, they decided to make their own standard. Like, it's just completely different to everywhere else. So we had to actually dumb down the technology to mimic the building standard. And the technology can by far outperform the building standard, and this happened when we tested. We had some tests, we are almost 10 times the required strength, which is ridiculously high. And in some instances, they couldn't even break the wall. So when we did the tests for the axial load test or the vertical load test on the road on it, we broke the ram that was testing the wall. So they said, okay, we're not going to try to break the ram again, and we will wait. So the test stopped, and the wall section can carry almost eight SUVs nose to tail, and it did not break. So it was very promising. It was very exciting, but we looked at it and saying, okay, we can do a lot more with a lot less material if we 3D print, and unfortunately the building standards are not keeping up with what we're trying to do. Maybe the United States being the first country that has the HABUL listing or testing procedure for 3D printing, and New Zealand were miles behind when it comes to that.
I wouldn't say the United States is far more advanced. They just came out with SG80, which is a kind of overarching regulation stating that they support 3D printed buildings, but it's up to local municipalities to decide whether they want to permit it or not. And so it's very fragmented, and it's not even at a state level, it's at a town level that the permitting department will have to determine whether or not they'll accept these types of buildings. So your training initially, what was your team like?
So, because as you know, there isn't an industry that feeds into 3D printing concrete. There's somewhere that these guys work in this industry, and then we can train them up to be there. It's just completely out of the box. And so what I did is that I have a certified builder, and he's young, and also a digger driver. So both of them can help each other out. So one of them is very experienced with machinery, heavy machinery. The other guy knows the building standard. And both of them didn't know anything about modeling softwares. They didn't know anything about robots. They didn't know anything about 3D printing when they started. And I gave them some training when they started about the modeling softwares that we use. And then when the guys were here training them, within 10 days, the guys that didn't know what robot looks like or how to even do basic movement on the robots, they were able to operate it and able to control the system. And we did a lot of video conferencing in the beginning, and through the CyBe's library, and we had videos that help us train the guys. And even before we actually had one-on-one training with them in person. We were able to print elements with the slow setting material to help us get familiar with the system. And then after that, when they were out, we were of quarantine. Feels sometimes I think that they're like out of prison. Felt like it sometimes. We were able to effectively pick up from where we left. Obviously, they have a lot of experience, so there's a lot of things that you have to learn hands-on. And CyBe's motto with learning by doing is perfect for that. It's just we had to get our hands dirty to learn it, and I can tell you we got our hands dirty and we got really hot.
So in the beginning, it was easier for you to print with the slow setting material, and then after the training, now you're mostly printing with the fast setting material.
Yeah, we're printing we can print with, we developed a local mix in New Zealand based on the recipe that CyBe have developed and produced in Germany through Qorox. And we had a lot of technical support from Qorox and CyBe to be able to get local ingredients to replicate the system that they have. And even in New Zealand, we had to think outside of the box because some of the sand sizes and statistic characteristics that you find in Europe were not available in New Zealand. So we had to effectively develop a whole new formula. And the guys have been really supportive, and it helped us a lot because we're so far away from the rest of the world. We're almost disconnected. It works very well in pandemic times, but it's not really good for logistics. So it was paramount for us that we're able to work with local material as much as possible and to reduce the impact of transport. And we got it, and right now we're even testing with colored oxides. So we're printing with today we printed with black mortar, so it's comes out black. And this is with New Zealand mix. It's not the mix made in Europe, and we couldn't have done that without CyBe's support, of course.
Very nice. So your initial team was the three of you, yourself, the building construction standards expert, and the heavy equipment expert. Has your team grown?
Yeah, they're not experts, but the builder is 22 years old and the digger driver is 25 years old. They're just young guys.
They're enthusiastic to learn new things, and they're getting
Exactly.
specialists within concrete printing.
Exactly. So right now, as far as I know, they're the only two guys in the Southern Hemisphere that actually got hands-on training, one-on-one training with CyBe. And I know that there's other robots that have been sold to the bottom half of the planet, but I don't think they had the luxury that we had when we managed to get the guys from the Netherlands here. It worked quite well because a week after that, we couldn't get them through quarantine because it was full. The quarantine facilities were fully booked, and we just managed to just squeeze them in. The quarantine facilities in New Zealand are managed by the New Zealand Army. So the first time we actually met, when they arrived, we were dropping some stuff for them, and there was one of the Army lieutenants, I think he was standing there, and he quizzed us. What are we doing here? How do we know each other? Why are you guys standing there together and stuff like that? But this is how seriously they take it here, and that's why we are able to move freely, and not freely really, but freely within New Zealand at least.
So the guy responsible for allowing you into New Zealand, had he heard of 3D printed construction, or was he like?
No, that was policemen and some guys from the army that guarded us. We were explaining because there were only people from Australia traveling to New Zealand, meeting up their family back and forth. So they had the Dutchies, us, over there, and we explained what we were doing, and they're like, you've really got the life. You're seeing nice countries like Qatar, Dubai, Paraguay. Now in New Zealand, you're able to travel. Although there is COVID, you're still doing these things. So no, they're really amazed of the lifestyle, as well as what we are doing. It's pretty unique, still on a global scale. It's pretty unique to print concrete. Wafaey is the first one in New Zealand who's doing this. So it's like being a frontier. There's still a lot of opportunities which we're capable of exploring. So yeah.
So it's very exciting, and we're getting a lot of interest, and we're working on some stuff that I don't think it's been done anywhere else in the world, but you never know who's doing stuff somewhere. It's not advertised yet, but in November we might have, or before the end of the year, we might have a world first with 3D printing. But I don't know. We will have to put them, in bold with lines on there. Most likely the first, or most likely the second, or whatever it is. But
these are because we've seen some things you're working on. These things are good to gain credibility. Whether it is the first or not the first, it gives credibility to the company who's doing it, for sure.
Exactly.
In the end, and grow your business, getting that credibility is relevant.
Yeah, I know, but it's very interesting because what we're working on, it's not the high risk element or anything. It's straightforward walls. But what are we doing with the walls? It's what's exciting. And generally speaking, the construction industry in New Zealand is a little bit risk adverse. It's really stagnant, and mainly because they're driven really very low margins and very high viability. So this doesn't give you room for innovation and trying things. A lot of the companies that I'm working with, they're young companies. By young, I mean the owners are young. the older the company or the older the architecture firm, the more conservative they are. And we found a lot more traction from small to mid-sized firms rather than the big ones. The big ones are interested in knowing what we're doing, but they're not really keen to be the leading edge of technology. And a lot of them, innovation is more of a marketing punchline than actual a goal that they are trying to achieve.
That makes a lot of sense, because the older companies, I mean, if the CEO is in his 50s or 60s, he's looking on the horizon of retirement, and this technology could take another 5 or 10 years to become super mainstream. So it's really not in their prospect to dominate construction automation, whereas the younger guys have that opportunity for the future.
That's one thing, but also if they are going to embrace the new technology, they need to start reorganizing and educating all the current team members, which is pretty a big influence on an organization.
Yeah, so one of the things that we're trying to do is try to work with the universities and have lectures and presentations with the professors and architecture or structure engineering, and maybe to make them aware about the technology and excite them about technology and get them understand about parametric design, because even in New Zealand 5 years ago, most of the graduates didn't know anything about parametric design. They were barely doing modeling software, predominantly using SketchUp or Revit. And now we're telling them, no, there's a whole different world out there called parametric design, and they're just, the older ones are freaking out. Then go on, really excited about it. And anyone from 30 and above is looking at saying, crap.
Can you tell me more about your personal background? Like, what job were you doing?
So my personal background is, my father had a construction company when I was when I was in high school, and I wanted to be an engineer for some reason. I didn't know what type of engineer. I just wanted to be an engineer because I was really good at math, physics, and chemistry. So I was saying, I need to be an engineer. So I went to engineering in Cairo University, and then after that, I realized I don't really like math that much. I had enough. Integration and calculus just drove me nuts. So I said, okay, which is the department that take the least amount of math? And it was architecture. So architecture, they have one course of the statistics, and that's it. So I said, yeah, that's me. So I graduated with a degree in architectural engineering, and I worked in construction in Egypt for a couple of years, and then I got a job opportunity to move to Dubai in 2006 during the construction boom that was happening over there. Ended up there for 7 years, worked on all sorts of projects, from fit out for super yachts to work on the Formula One track in Abu Dhabi, and did the Ritz-Carlton Hotel in the IFC, and then got a job opportunity to move to China. With my last employer, they asked me, we're going to close the Dubai branch because the economy wasn't doing so well. They want to go to China. So I said, yeah, why not? So I moved to China in 2013 and lived there for 2.5 years. Did a couple of really big logistics centers over there. And then moved 2015 to Hamilton in New Zealand. It's a long way around, but eventually we made it to New Zealand. The main reason why I ended up in New Zealand is my wife is from Hamilton. And at that time, I was planning to move to Canada, and she told me, I'm not going to move to Canada, it's too cold. So I ended up moving to New Zealand. So I worked here in a construction company, specialized in design and build projects, mainly complex laboratories and factories. And then in 2018, you can call it a midlife crisis, you can call it being bored of the construction industry, you can say whatever you want. I lost all of my hair over the last 20 years, and I said, I'm not going to continue doing this crap over and over again. The construction industry either need to change or I need to look for another industry. And I found a couple of videos about 3D printing online, and it was really interesting. And the more I read about it and more research I did, the more interesting it it became to me, and it became quite obvious that this is the future of construction industry, because we cannot keep on repeating the same answers to the questions that we have, the pain points and the questions that we have as an industry, and expect that somehow it's going to fix itself. And the only way for us to get out of this construction rut that we have is by implementing automation. Automation needs to be part of the everyday construction. And we need to be more sustainable as an industry. The amount of waste that we have in construction sites is ridiculous. And the only way to be efficient is to actually be more accurate and more precise in what we're doing. And automation is the only way that allows us to do this, because robots are a lot more precise than humans. And that's why the automotive industry have embraced this for 30 or 40 years. The construction industry is just catching up with the automotive industry and manufacturing in general. So manufacturing should not, or automation should not stop at the factory door, should not stop where the raw materials made. Because again, if you look at the supply chain of the construction industry, most of it is automated until the factory door, and then this is where it stops. This needs to flow over to the construction site. And whether you're doing precast panels on site or semi-precast panels, or you're doing print in place, whatever you're doing, it's way faster than doing it with physical labor. Whatever printing system we have, it's faster than doing it manually.
So let's talk a little bit about the economic factors in New Zealand. How is the labor market there for construction?
And I think it's quite similar to a lot of places around the world. We don't have enough people, and this is one of the biggest challenges. And it seems to be the default answer is that we need to train more people and get them to the industry. And if this solution worked 30 or 40 years ago, we'll not be having this discussion now. But this seems to be the default answer everywhere in the world, and you end up with either migrant labor, or you end up with a big surge of untrained, unqualified, or unexperienced workforce that actually causes a lot more damage than benefit. And the solution is not just train people or import people, because in Dubai, the majority of the workforce were migrant labor. And right now, you will see that Dubai and Saudi Arabia and the GCC overall are the ones that are investing the most in 3D printing, because they know that this is not a sustainable model with migrant labor, because migrant labor come in regardless of where they are. They need food, they need shelter, they need medical service, and they're also not there with their family. So either they want to bring their family, or continuously they have to travel back and forth. And it's quite obvious that's not sustainable, and COVID made it even worse, because closing the borders down, the migrant labor is either they're stuck in one end and they either cannot go to the family, or they cannot go to the countries that they are going to work in. So it's quite obvious that we need something else to do the heavy lifting rather than human resources, and robotics and 3D printing is that.
What about the housing market in New Zealand? Is there a housing shortage? Have the prices been rising dramatically like in some other regions?
It's borderline a joke, and what we have here, like we don't have enough houses. Again, it's a global issue. Housing prices, everyone expected during COVID and lockdown that the prices will go down by 10%. As a result, they went up by 30%. So interest rates are lower, and they're blocking effectively investors from buying property. And banks are putting a very high deposit requirements for investors to try to protect the first home buyers, the people that want to buy houses for the first time. And what's being put on the market is nowhere near the requirements. And this is mirroring what is happening everywhere in the world. And this is also reaffirms that the construction methodologies that we're doing are not keeping up with the demand. No matter how big or small the scale of the economy is, you have the same issue in the United States, you have the same issue in Europe, you have the same issue in India, you have the same issue here, you have the same issue in Australia. No matter where you are, it is the same problem. Not enough people, not enough time. Cost of construction keeps on going up, and we don't seem to have an answer for it. And with the traditional way of been doing it, because this problem has been around since the 50s and the 60s, and post World War II, when they had to rebuild Europe, it was the same problem. Not enough people, and Europe ended up relying quite heavily on migrants from Turkey and Italy to rebuild it after the Second World War, because there were not enough people, and it stayed like this.
Are there states like this? You mean in America?
No, I mean state like that. The state the demand for human resources is not able to fill the gap, and the supply has been always short.
Understood. So in America, they do a lot of like stick-built construction. In Florida, they do a lot of cinder block or concrete. For bigger buildings, maybe they'll use steel. What's the conventional construction method in New Zealand?
The convention is stick framing or timber framing, which is very similar to what we have in predominantly the United States and Canada. We don't use auto masonry blocks or cinder blocks because we lack the skill force for plastering and rendering. And timber is a local material. New Zealand exports majority of its timber because we have a very green country. So we produce pine and we export pine, and we mill it. So most of the timber framing we have in New Zealand, or not most, all timber framing is pine, and treated against termite, and not termite, against moisture, and we don't have termites in New Zealand. It's too cold for termites, but in Australia they have termites issues. But in New Zealand, 95% of the houses or even more are timber framing. We have very small percentage of steel framing. Again, it's mainly because what is the workforce used to? So they use the timber framing, and that's what they use. On the flip side of that, even though we are exporting timber, we have a timber shortage, and also we have we're relying quite heavily on treated timber from overseas, for specific bracing elements and cladding that we don't produce in New Zealand. So we import a lot of cladding timber from Canada and the United States, and a lot of plywood from Australia and China, and we're short on everything. Right now it's quite difficult to get timber, and timber prices went up by 20% since the beginning of this year. So you add to that shortage of labor, you add to that the country would close borders, so we cannot even get labor if we want to, and you have a recipe for a disaster, really. And this is what we're going through. We have the highest consent, or the highest building permits for housing ever recorded since the 70s. I think it's even surpassed that. But we'll not build them because we don't have enough people, and we don't have enough material. And New Zealand, being a small economy, will rely a lot on imported raw material. And Europe waking up right now, getting out of lockdown and going to summer, there will be a massive demand because they have a massive backlog of construction, and will absorb a lot of the raw materials that's going around the world, which means that we'll be left out because our buying power is quite small compared to Europe or South Asia. So it will compound the problem. 3D printing, on the flip side of that, it's completely parallel supply chain, so it's not affected to what's happening. So it helps us elevate some of the pain point and the shortage in raw material that the market will have in New Zealand, and this makes it even more attractive to a lot of people because you have the product, you can print with it, you don't have to wait for the local manufacturing process at a full capacity.
Very nice. You mentioned a project in November that's going to be maybe a first, or at least first for New Zealand, probably globally. Yeah. Can you go into any more details about what that project will be?
Unfortunately, I can't now. I don't think even Barry knows about it yet. So it's a little bit keeping grabs on it, and hopefully, because we have annual maintenance with the guys from CyBe, so maybe they will be involved in it if everything lines up, because it will be a very cool thing to do, and it might be also a first for them unless they have done it somewhere else. But as far as I know, it hasn't been done, and it's exciting, and the client is ready to go. It's just we're finalizing the dimensions to get the engineers involved and build it. So just there's engineering involved in it, if that helps. Gives you any hints.
So what are your favorite prints you've accomplished so far with your CyBe printer?
We have this kind of unique flax weave. So in New Zealand, they use flax as part of the Maori culture, and they make baskets. It's quite similar to what you'll have in South Asia with palm leaves. So we printed a wool that mimics the Waikato River, a section of the Waikato River with flax leaves in front. We did it the first time when we're doing the training. Actually, we did it like within the first week of doing training. After the public demonstrations that we did in Auckland. And after that, now we pushed it even further. So we have more projection, and it's everyone that looks at it, they're really it stands out, because you cannot do this with any other construction method, unless you're willing to spend thousands and thousands of dollars in molds. But yeah, I don't think you can do it, because even the wool is curved. So it doesn't just have the pattern in front, it's curved from behind, and with precast, it's very difficult to do curved wools with texture in front. I can send you a picture of it, and we have a small time lapse of how we did it, and we're printing at around 4.5 square meters an hour, which will be around maybe 4.5 square meters a foot would be around over 40 foot an hour. And if I remember, it will be maybe close to 48 foot an hour.
Would you be able to use the share screen option to put it on this video chat?
Yeah, I can. You need to enable me, because it disabled participation by host while I'm looking for it.
I can't, it won't let me change the setting.
Now it's worked.
Okay.
Now it's working. I just need to find the picture, and I will show it to you.
So what is from your side, the support provided?
I think the entire process can be divided in different stages. Of course, in 2008, we talked about, he contacted me when we were in Saudi Arabia in August, September 2018, and we scheduled the visit to get to know each other in October 2018. Match was pretty good. He's from a construction, he's got a construction history, as myself. Both have been in Dubai, so I knew where he was talking about. Based on that, you can really build up a relation. First, we focused afterwards on the business case, and in parallel, indeed, it was necessary to get a wall section getting certified in order to get the funding arranged by the end of 2019. So what we always do is focusing on the business case, and make sure that within the business case you've got a design or something to also check, besides the economic feasibility, the technical feasibility. I think within 1 year we cope up with that, and then indeed we started manufacturing the printer into the beginning of 2020. As a result of COVID, we had some delays as well as with the training. The training would have been here, but I think in the end, 2020 was pretty stressful because we couldn't do what, also for him, for Wafaey, it was stressful because we didn't know what to expect. April, March, April, May. But I think in the end, November, when we were there, seeing each other again, because it has been like 2 years that we have not seen each other, and everything is now falling in place. And that's indeed hands-on training, being there physically, supporting not only with the printing, but also meeting up with the person, in this case, Matt and his team members, talking with several interns that are working at Qorox, supporting with the material, doing that together. And now as well, Mark, who has been training you for the last 2 weeks, he's got a bi-weekly meeting with Matt and with Wafaey to see what they're up to see what they need additional support. And for us, that's also relevant because we get feedback by which we further develop the training programs or our technology, the software, etc. Because they're also using it, so they know best where we need to tweak. So that is actually providing us relevant feedback that they give, as well as all other partners we have, to further progress on the technology.
And Garrett, for some reason, is telling me sharing the screen is paused, and I have no idea why. I tried to press on resume sharing, and it will not let me.
There we go. You should be able to now.
Okay. Where did it go? No, it's gone. Okay, let's try again. Okay, so this is, I don't know if you can see the picture. This is when we did the public demonstration in Auckland, and you can see here the curve in the back of the wall. Can you see the picture?
Yes, there we go.
Okay, and I will just jump. And this is us printing, and you can see the Mark and Kevin over there. And we were printing the wall. And this wall was 2 meters long and 1.5 meters high, and it was printed in 35 minutes.
In broad daylight with no tent or cover?
Nothing. We were just in the middle of a big square.
They got back, they were so burned.
Oh.
Yeah, so everyone came back with a very good tan or a burn. In Kevin's case, he got really cooked. But we have done it. And this is how it looked like. And this was printed. The guys came out of quarantine on a Saturday. This was printed on a Friday. So we met on Saturday. We looked at each other. We had a barbecue and beer. And then the next day we didn't. I think you went hiking. I took you hiking. I think for a hike. And then. First day, Monday training, Tuesday, Wednesday, we printed our first bench for Auckland Council. Thursday, we did the Hamilton Council demonstration. Friday, we printed this. This is how quick you could be trained and operating the system.
The tiles on the floor are more red, or Kevin's leg are more red?
We don't really know. This is a mystery. No, it's a big square there in front of in the middle of town, and it's part of what's called it's next to the theater in Auckland, so it's a big space, and also next to Auckland Council, who now are one of our customers. I'm just trying to see the actual wall.
Although there was COVID like around the world, there you don't have had any measurements. So there were like 100, 200, 100, 150 people invited and being there watching print. You don't see them because they're like behind the camera. Because we made some movies about it. But as a result, see, oh, it is possible, and then that's really important. See it for real, not on a YouTube link or whatever. And based on that, from his construction background over there, so they can get in contact, and as a result, he gets a good traction nowadays.
Yeah. So this is the first print, which was the day before. This was done in Hamilton, in the middle of a square. Again, no cover, nothing. You can see a lot of people standing there watching us. And we printed this module there. It's 2.8 meters high. Nice. And 1.2 meters wide. It was printed in an hour. And again, you can see Kevin there in the corner. And now it is, and that's the back of it, and that's our robot there. And this is, you can see the robot is clean, brand spanking new, did not get any concrete splashing on it yet, because we just started. And this is the day before when we printed the other seat that sat in front of it, and this is the big module in Hamilton, the middle of Hamilton, and this is the other one. I have some pictures of them when they're completed. Every time I close the window, it kicks me out. But
I also think this is a nice thing because what Wafaey is focusing on, like yesterday we had a meeting with our partner in Curaçao. They are saying, yeah, we can print walls that you can see there, and they're focusing on printing walls of buildings. But we can also use the machine easily for printing street furniture, benches, artificial reef, etc., etc. So as a result, we can fill up the equipment. And the nice thing is we can share. Wafaey can share things with us. We can share them with our partner in Curaçao. We can share things with partners in Morocco. They're sharing things. So as a result, you're creating this community. And then the effort of every single partner is getting less.
This is the same wall after we printed it recently. And you'll see how it changes, how much projection we're getting out of it comparing to the previous one. This is when we're getting comfortable with it, and we're getting more experience with the material. I'm sorry, it's a little bit jittery, but it's got sped up from phone footage, and you can see right now if you compare this to what we have done in Oakland, this is a lot more projected.
Yeah, that's an identical 3D model.
Yeah, it's identical, but we push the limits a little bit more because if you imagine that you got you're doing a public demonstration in the middle of Oakland for the Oakland Council, who is the biggest council in the country, and you don't want to really push it because you're in public. So we were a little bit conservative on how much projection we did. Plus, we are only headed for a week. So we only use the robot for a week. So we cannot really, like try to be world beaters when you only had something for a week.
Yeah, it's a classic engineering problem that you test something 100 times in the lab, it works every time, and then you take it into public to show people, and then it doesn't work all of a sudden.
Exactly. It happened to the Tesla demonstration. It happened to us.
And if it happened to them, it could happen to anyone.
Exactly. So the whole thing is that we're trying to make it how can I say
Reliable.
Yeah, we're trying to make it unique. And there's recently a project that we actually walked away from it. It's not because we are arrogant or anything, but because what happened is that we had around 80 linear meter, which will be around 240 foot of wall. And it's a retaining wall for landscaping. And they just wanted to plaster everything. They wanted to plaster the front. They wanted us to cut the corners because they didn't want to have any rounded corners. They wanted effectively to strip 3D printing and dumb it down to something else. So we ended up telling them, you're getting a race car and you're using it for grocery shopping. So I told them, you want to have a masonry or cinder block look and finish. Use cinder block. Don't use 3D printing to try and make it look like cinder block. And And we ended up walking away from the project because we didn't believe that this will showcase the technology or the benefits from the technology. We will be way faster. We would have done everything in 2 days. And it would have taken us 1 day to install it. But we had to walk away from it because it's not really showing the technology, it's dumbing it down. And we don't want to be dumbing down the technology. We want to show the advantages and the benefits from it. What we think is the best thing is that to do the least amount of post-printing work as possible to it. And this is where you get the maximum efficiency from it.
I think it's an old school way of thought to like hide the construction methods and have like fake wood vinyl paneling or a drop ceiling and all these other methods of like disguising the true nature of the building. Most of the forward-thinking architects, and I think the way architecture as a whole is moving, is showing the construction technique in the building, leaving the raw ceiling exposed, leaving concrete exposed, even leaving some steel exposed, because people appreciate being able to see how the building was constructed, like timber frame, even cinder blocks sometimes, brick. These things are now being left exposed. And I think 3D printing has phenomenal contributions to make to that, because it can be created in any form you want, design, whether it be a basket weaved pattern like you mentioned, or the diamond pattern. Most of the patterns that are possible certainly haven't even been experimented with yet. So I think people in the future will be much more willing to accept the design as it is, rather than just wanting to plaster over it and hide the nature.
Yeah, you're that right. Because also when I do presentations and talk to architects about it, most of the people that wanted to look flat and smooth and are the senior guys in the firms. Generally speaking, the square, clean look is driven by an older approach, and not trying to make it dynamic and organic to blend with the environment around it. It's more of an imposing kind of architecture that this is us, this is where we start and this is where we finish. But if you look generally about all of the new designs that are coming around the world, not just with 3D printing, but even stadiums designs for the World Cup next year in Qatar, all of them are a lot more organic, are a lot more dynamic buildings. You look at it and you feel the lines work together and not butting into each other. They are complementing each other. And this is when 3D printing really helps this. A lot of the reason why it was a square-shaped buildings, and especially when you look at industrial buildings, even in New York, if you look at the Twin Towers previously, the only thing that made them impressive is that they were tall. If these buildings were 10 or 20 stories, they would be one of the ugliest buildings on the planet. But what made them impressive is that they were tall. Compare that to Burj Khalifa that was built in Dubai, and you compared the designs of them. Right now, it's the tallest building in the world, and you see how organic and how dynamics looks. Not a box that's stretched for hundreds of meters above ground. And you look at the new towers that's being built around the world, or resorts or anything like that, that they are trying to integrate with the environment around it rather than being imposing. And the main reason why they were doing squares is because it was easier to build.
20 to 30 years, the capabilities of design and structural engineering, they increase as a result of using software tools like Revit, like Tekla, etc. As a result, designers, whether it are architects or engineers, they could create more complicated or more organic designs. However, the construction methodology, they were still the same. So now with printing, now start coping up, and they can actually push each other's boundaries, which actually now just opening up all the capabilities that we have not been capable to build like in the last 40 to 50 years. And of course, besides that, you've got those unique buildings like the Burj Khalifa, etc., etc. But in the end, social housing probably will be like straightforward, quickly being built, and that is actually the majority of all the people globally are going to. And with that, actually, I'm going to leave this meeting because I need to go to my next meeting. I will talk to you like in 1 hour or so.
Okay, no problem. Just send me a message and we'll wait.
Okay, cool.
Yeah. Okay.
So, designs that you shared are mostly a lot of furniture, some walls. It sounds though like you have ambitions of constructing some buildings.
Yeah, we are, and we're working on a couple of houses that we're designing, not designing, but involved in, and we have some walls that are quite unique in design, and this one of them, for example. So this one here, CyBe had made that design initially, but we tweaked it. And this wall is 2 meters by 2 meters, and it was printed in 38 minutes.
Nice.
So 2 meters, which will be around maybe 6.5 foot or almost 7 foot.
Yep.
7 foot by 7 foot in 38 minutes. So there's a couple of houses that we're actually working on now, and they will be built towards the end of the year, but none of them are part of the maybe world first thing, because houses are obviously have been done, and it's in the pipeline. It's taking a little bit longer. We have been working with group house companies that are developing their own range for 3D printing houses, so optimizing the designs that they have for that. We have a lot of interest from the social housing perspective, but the governments work in a very different rate to private sector. So private sector obviously is getting on board quite early, but with councils are really excited about using it for street furniture and landscaping, because it's very durable construction method and gives them a lot more freedom in design. Like Barry mentioned earlier, there was a lot of designs that could be done that couldn't be doing them with the traditional methods of construction, and also methods of designs and structural analysis that right now is becoming very, very common.
So for the houses you plan on building, will you print the elements for the house in your facility, or will you bring the printer on site?
Well, we didn't decide on that yet. We have both options. We can do it off-site and take it on-site, or we can take the robot on-site. It really depends on the access that we'll have to site at that time and what stage the project will be in. It's a little bit tricky because the house is on an island, so it's not New Zealand's an island. This one is an island of New Zealand. So it's a small island, and the land is quite steep. So the house will be cantilevering over it. So it's going to be a little bit tricky to have access, but we're doing everything we can, because the client wants a printer on site to showcase the technology, and it will be good footage if it's on site for our marketing material. But generally speaking, we would try to do what's the best for the project and what's the best for the client. If it's the best for the project to be on site, to print on site, we have the ability to do that. And we have done several public demonstrations that we arrive in the morning, we print, and then by the end of the day, we take the robot back. So it's not difficult to do that. Or we can have a printing area or a printing station on site that we're printing everything there, and then we get positioned the final position, or we can print on the final position. So having a mobile system gives you all of the options. And one of the things that we have is that we have limitation on the length of the wall elements that we can print in one time. And this limitation is imposed on us by the building standard. So we cannot print the walls of a house continuously without having construction breaks or construction joints in them. So this limits a little bit our options when it comes to what type of systems we can use in New Zealand, because if you must have a construction joint every 6 meters, which will be around maybe
18.
18 feet. So if you have every 18 feet, you must have a construction joint. There's no point trying to print 30 feet. You know, you'll go around and start cutting the wall again. So, because this is the building standard, and a lot of it comes back from how seismically active New Zealand is. They call it the New Zealand nickname is the Shaky Isles, which is short for Shaky Islands. It's the same like Japan, but which makes the seismic requirements quite high. The closest thing you can have to it in the United States is San Francisco area and LA and maybe California. But here we had a big earthquake in Christchurch maybe 10 years ago now, and or maybe more, and it was really devastating for Christchurch town, which is the second biggest city in New Zealand. The CBD was completely destroyed, and they had a lot of fatalities, and this instigated a review in all of the building standards, and we changed a lot.
So quickly weighing some of the pros and cons of on-site versus off-site, it seems to me like it would be easier for you to ship in the raw material to the island rather than ship in the printed elements, because if they're on a boat or something that's shaking, rocking, you have the risk of the printed element getting damaged or cracking or like falling over or something. Whereas the concrete sacks could it doesn't matter how much you put them through.
Yeah, you're spot on. And the advantage of printing offsite in general is that you're working in a controlled environment. You have your power just there, you have your water there, you don't have to worry about whether you are in control of the elements around you. And you can work 24/7 because you have lighting. When you print on site, you need to take the robot, you need to take the raw materials, you need to have utility over there, whether it's water, power, or waste. And waste, obviously, because you have some wastage. So at the end of the day, you have to take something to site, whether it's a finished product and you take the risk of logistics of it, or you are taking the machinery and the raw material there. And at that time, you have to deal with the site conditions and you have to deal with the utilities or services that you need over there. So unless we are printing with dirt like WASP did previously, and having the building standard accepted, we will have to take something to site. So the biggest thing is every project is unique, and the best thing that we can have as preparation wise is to have the flexibility to do it in any way. And a lot of the times people get fixated on the system more than the clients need and what they're trying to help or trying to achieve. And they try to pin one system against the other. But the way I look at it is that every system has its own advantages. And in certain situations, one system might be way better than another system. And in other situations, the other system will be better than the other system, particularly robotic arms and gantries. They always have this debate, which system is better. But you think about it, you compare, the closest thing I think about is gantry cranes and mobile cranes. Gantry cranes are very good in certain situations that do stuff that mobile cranes cannot do. Mobile cranes on the other side can do stuff that gantry cranes cannot do. So it's not which one is the better, it's just both of them are different and they're better in their own areas.
If you need breaks in the wall anyway in New Zealand, then it seems like a no-brainer to me that you would use a robotic arm versus a gantry system, because the only benefit really of the gantry system is the monolithic structure. If you can't print a monolithic structure anyway, then what do you need volume for?
Yeah, and if you look also at having a robotic arm on a track that can print longer elements, we are also limited. If I have a track, it will be a very short track because I can only print 6 meters, and the robot reach on either end also reduces the amount of track that you need. So it will be a track that maybe runs for 2 meters or 3 meters because the robot reach itself. It's like we printed a wall element last week. It was 6 meters long without a track. So if I put a track, it will be like this long. It will be very short.
Sure.
And so and again, I'm not trying to say there's one system that's completely better than the other, because I don't think, honestly, there is. If you want to be flexible and print on multiple sites a day or every other day, the gantry system setup will not help. In the same time, if you want to have a monolithic look, gantry systems are better than mobile systems because you can do that. You have other things that take into consideration about material shrinkage and curing and other things that you have to take into account. On the flip side, with robotic systems is that they're so fast, the material that you need to use has to be very quick setting. And you have to know how to use it very, very well. So it's less forgiving with speed. You have less error tolerance. With gantry, you have longer elements and more tolerance and workability at time. So as you can see, they're different, but they're doing the same job to a certain extent. And you will notice that a lot of them have also very different look and feel. You'll see gantry systems most likely have thicker, higher layers. Mobile systems have finer, lower layers that are more homogeneous with each other because of the how can I say, the short tool path that you have and the short time you have between layers, so it helps with adhesion. A lot of the time when you look at big gantry prints, you'll see that the layers below are completely cured if you compare it to the top ones. With prints, most of the time with robotics, the bottom layers are still not 100% cured when you're at the final layers. What gives you more of a consistent structure from bottom to top. You don't have any cold joints that happens from there.
I haven't seen any gantry systems printing full height walls all at once. They usually print a portion and then wait and then print the next portion. You mentioned—
Yeah, because...
Go ahead.
Go ahead.
Oh, you mentioned printing with mud or Adobe, like WASP. Is that something you're—
Not yet, because the New Zealand building standard will not recognize that unless we're doing pot planters or something like this, and you're doing it with very slow speed, and you'll bake it after this. It's not gonna be recognized. And this one of the challenges that the industry generally have is that even try to talk about geopolymers or putting waste concrete in the concrete structures, or I always get asked about hempcrete. Can you print with hempcrete and all this stuff? It's just the material, unfortunately, needs to prove its durability and longevity and the low maintenance work for the building standards to look at. And all of these materials are still in research phase. So I don't think there's one factory that produces hempcrete all the time, because what they do is that they get normal concrete and they put hemp fibers in it and off you go. This will not work with any of the pumping systems that for 3D printing, and also the look of it will not be acceptable because you will have hemp fibers coming out of the wall. And we're talking about organic designs, but this will be a live design. The wall will you will have weeds growing out of it. But the biggest thing is how regulation looks at new technology, and you touched on it. And also speaking, even the United States, with this fragmented system that they have, or the fragmented beginning of a system that you have, is way ahead than a lot of countries around the world. We don't have anything anywhere near recognizing 3D printing as a construction method and how to measure its performance. When I talk to structural engineers in New Zealand, one of the biggest challenges that we have is that the only thing that concrete can work only in compression. And this is very true when you have a solid piece of concrete with no reinforcement in it. But when you start to do honeycomb structures, and you start to transfer loads, the concrete in one direction is working as compression, and the other way it's complementing itself. They cannot get their head around it, because also the softwares that they use cannot calculate concrete in this way. So it makes it, even if they want to, they cannot prove that it works. So it will take time, and there's a lot of companies that recognizes that this is a gap in the market that they can fill, and they're starting to develop their own 3D printing concrete analysis software. So you can show to structural engineers that, okay, with this infill pattern, we can achieve so much more, or we need to infill spacing to be so much to allow us to do that. This ultimately will reduce the amount of concrete that we'll be using and make the buildings a lot more sustainable. And we'll put a little bit, we'll take the focus away from the construction industry being a non-sustainable practice or a non-sustainable process, because we're using our material that we have way more efficiently and doing it purposefully. We are putting concrete there because we really need the concrete there. A lot of the times what happens is that you're filling the walls, and as a result of filling the walls become heavier. So you need more reinforcement. And then the more reinforcement you put, and the more thicker the wall gets, and you end up chasing your tail a little bit until you find the optimum design, the wall to concrete to reinforcement ratio. And right now we're even telling them you can use less ratios than you have. So in building standard in New Zealand, there are specific ratios of reinforcement, minimum reinforcement in the concrete. But what we're trying to tell them, no, you can do less if you do a honeycomb pattern or an infill pattern, because you're getting the concrete to work very differently than it was before.
Which is really only possible with 3D printing. I think you have a good chance of having the first printed building in an earthquake zone. I don't think that's been done before.
I don't know, because if you think about the guys like Mighty Buildings in the States, they're in California. They have done that.
Building.
Sorry?
I wouldn't count Mighty Buildings as being a 3D printed building. They don't use a very small portion of their building is printed.
I understand, but what I'm saying is that everyone can lay a claim left, right, and center about that. If somebody builds something actually India is considered a seismic zone, and they have printed something in India. I'm not trying to say we're not trying to be innovative or trailblazers, but I'm very cautious about saying the first or the only or that, because
about it that way, it's less important to be the first and more important to be the 100th or the 1000th and actually implement it at a large.
Exactly. I'm with you. And one of the things that I really liked is that when you did the video about debunking the $4,000 house or the $5,000 house, it's mind-boggling how things get stretched, or the media coverage of how sustainable it is. And it's actually doing the whole industry a disservice, because what this does is that it freaks the existing market from us and from the new technology, and you're creating enemies because you're thinking, oh, they can build it cheaper than us. No way we can do that. It costs us $4,000 just to wake up in the morning and to send our crew to site. And I think 3D printing industry or 3D printing community overall, we are falling victim, or purposely or unpurposely, of exaggeration and putting a level of expectation, whether it's time or cost or speed of building, that is not realistic, and it's actually stretching the reality.
Yeah, I definitely agree with that. It's an interesting duality, though, because you mentioned you saw a video about 3D printed construction. It was probably one of those videos that said $4,000 house or $10,000 house printed, wasn't it?
It was a $48 study, a 48-hour study that was printed in Russia. And you looked at it.
you have to be kind of thankful for that false marketing, because that video got so popular because of the claims, and that got you interested. Same with me. That was the introduction I had to the industry. And we were just some of the few people who didn't give up after we realized it wasn't a reality.
Yeah, because you can see through this fog. And also it's, and one of the things that I really liked about working about CyBe, and I don't want to look like I'm just promoting them just because they're my partner, is that they don't leave you alone. If there's a problem, they will do everything they can to help you. They don't just sell you the printer and tell you, okay, you go and find your own material, or you sell you the printer and run away from it. Or and Barry and his team, they really care, and you do, and you work with them and you know them personally. Like when they moved when they were in New Zealand, they stayed with us in our house and my father-in-law's house, because they were already locked up in a hotel for 2 weeks. So there was no point to put them in another hotel. So having a sense of normality was important, and I don't think you can build such a relationship with other company owners, even though they might be accessible by email or phone. But this level of attention and support, I don't think you can have. You can easily have. The thing is that we feel that's really a partnership, like we're in this together. Their success is my success, my success is their success. And a lot of times I feel that the 3D printing community overall needs to collaborate more. And we'll be a lot more stronger, we'll be a lot more efficient in our R&D, especially because there's a lot of startups that are doing a lot of very cool stuff. And we need to talk to each other and collaborate with each other, because there might be something that's developed by a company that another company that's just about to start developing on their own. And we can speed up the whole evolution of the industry if we just collaborate together and work together, rather than saying this is better than this, or we have done this, our system is better than yours, our material is better than yours, or our software is better than yours, our robots is better than yours. So instead of trying to push each other and say who's better or who's the best, maybe it's better just to talk to each other and find out how can we work and speed up our progress overall.
Yeah, especially in these early stages when it's not like really tough competitively. Like you're the only company 3D printing concrete or mortar in all of New Zealand. And so you can share with other companies in India or in America, South America, Europe, and not concerned about it.
Yeah, and also there's enough work for everyone. There's enough interest about the technology that every single company that's doing 3D printing right now can have work for the next 5 years without even having to tender against anyone. Like, this is how much work is out there to get. The only challenge we have is that we need to win the hearts and minds of the average Joe, that to understand that this is actually a solution to the problems that they're having. And it doesn't help if we are building an unrealistic expectation levels when it comes to speed and cost. And also, it doesn't help if we're fighting against each other or arguing again with each other. Who's better, who's best, and all of this stuff. And we'll be a lot leaner and meaner industry if we just work together.
Yeah, I agree. So when you were going through the purchasing process, were there any other companies that you considered?
Yeah, there were a couple of companies. I don't know if I should say their name or not, but they're some of the biggest players in the market. And I talked to them, and ultimately I ended up working with CyBe. And some of them are predominantly, they might have sold more printers or similar size or similar quantity of printers to CyBe. I don't know. It's a little bit unknown because of all of the non-disclosure agreements that people sign, and what we don't know what's in the pipeline. It's a little bit. I honestly, when I started to research it, I started to feel that looks like a fog of information. You have to go through a lot of, deep dive research to actually find who has printers for sale and who is actually worth working with. Because if you look at the amount of companies that have printers for sale, I think you can count them in one hand. There's a lot of companies that have printers, but they are not for sale. And a lot of them can sell you a printer, but they will not be able to help you with the material. So it is a little bit tricky.
Yeah, certainly.
You have traveled around the world and you have seen a lot of printers in action. Can I ask you a couple of questions about what you have noticed? You don't have to be specific, but what have you noticed about the industry overall? What the biggest takes from it?
You hit the nail on the head when it's like, it's not about who's better, it's about the situational circumstances. And so it depends regionally where someone wants to print. Is it an earthquake zone? Are they limited by things like element length? What material do they want to print with? What are the priorities, whether it be time savings or like how strong does the material have to be, insulatory properties? All of these questions can change the scales of whether one company may be preferable to a specific region or project than another company. And so it's, and they're also all developing. So all the companies I'm talking to are, whether they're selling their printer or they're just working on a printer for themselves, they're still on a learning curve where they're adapting their printer and like making improvements. And so they're not unsatisfied with where the technology is today, but just because the iPhone has like great specs or great camera, whatever, next year they're still going to come out with a new iPhone. And then the year after that, they'll come out with another iPhone. And
it's like making the first iPhone and then stopping. Yeah. Okay, we made the first iPhone, we don't need to do anything more. It just stops there. I tell people that the printers that we have right now are the equivalent to the first laptops. So this is the first generation of these machines. And no matter what we think, the next generation will be better, and the next one will be better, and the next one will be better. But what I'm saying is that it seems that there are some companies are developing newer production lines or newer models that are already being done by other companies, and they're developing it from scratch. So why develop it from scratch when somebody's over there that you can go and talk to them and find out what it is and collaborate with them, and you can start producing your system in collaboration with these guys. It will save you a lot of time and a lot of headaches, and because you can take their learnings and work with it. But what's happening is that people are developing stuff because the other company has it, so we have to develop what they have. So we're not missing out, and we're developing it completely from scratch instead of talking to them, and we can work together and speed up. So if we collaborate, then the next generation will be better, and it will way better, and it will be a lot closer to become available on the market, comparing to waiting for everyone to do everything on their own. And I think it's part of it. It's a human nature. I would like to see 3D printing work the same way like Android did. Like they work with everyone. They allowed everyone to develop their own interface on it. They work with the companies work with Google to develop it, their own systems. But we are not there. We need to be there. We need to work together because a lot of the companies are, as you said, startups. They're still evolving and developing. And if you can take the lessons from someone else, instead of you wasting time and resources to do it, why not?
It's especially difficult for the companies that have received large investment from like institutional investors, because they have a standard for their companies and their like information, and they really are particular about not sharing the information that their investment has yielded.
Yeah, I understand, and but I'm not saying. But also, all of this time, there is always areas of collaboration. And if you turn around and you tell the investor, okay, we're going to collaborate with these guys to increase our range of supply, instead of us spending whatever the amount is and spending wasting a couple of years, we can work with these guys and have it available on the market next month. You think the investor will come and no, I want you to limit your product range. I don't want you to reach this market now. I want you to wait for 2 years, so you're only one that has the IP. But you look at that and you think the automotive industry again, because they seem to be a lot more efficient. All of the big manufacturers working together to develop a single charging system that will work on all of their vehicles. You don't think any of these companies could have done it on their own with the billions, not millions, billions of dollars that they have for R&D?
Have you identified any other companies that are more open to collaboration in this space?
I haven't talked to any other company, to be honest with you, but I know there's a lot more collaboration happening between the material suppliers and the companies, because the material suppliers are working with different companies, and they're working with them because their motto is, I'm not gonna have exclusive rights with anyone, because they want to sell to the whole market. We need to implement something similar to that to us. I'm not saying everyone needs to collaborate with everyone, but I'm saying is that if you don't knock on the door of other companies to try and work with them, you will never work with. I'm saying it could be collaboration between 2 or 3 companies that are working on a certain project or working on a certain product or a certain model, rather than each one of them, because right now every one of them, every single company is working in a silo, covering their IP, not letting anyone do it, signing very strict agreements with their partners around the world or their customers to make sure that this IP does not go outside. So each one is just have a little thing and they're trying to protect it. But also not a lot of the companies have massive investments funded into them to just make them lock the IP. So I know CyBe is privately owned. I know some of the other companies are privately owned. I know TAM is privately owned. I know Picas is privately owned. I know Petram is privately owned. There's a lot of companies. Copod is privately owned, as far as I know. So all of these private companies that then get venture capitalist funds or VC funding can work together. And there's nothing stopping them. It's just the own. And the good thing is that the owners of these businesses or the founders of these businesses are still running the businesses. So you can get traction and decision making very quickly, because if you can reach the founder, they're still running the business. They can talk to each other. You know, like you have this, we have this. They want to have a look at that, and we have a look at this, and that's it. You know.
Yeah, you need a big group chat.
Yeah, we need a big group chat, but I don't know if the first thing before the big group chat is that we need to stop poo-pooing each other and saying my cake is better than your cake. We need to celebrate each other's success, because everything, if there's a house that's built in Germany or a house that's built in the States or a house that's built in Dubai or a house built in Japan, whatever it is, it helps the industry overall. It helps us as a community, it builds awareness about it because it gets media coverage. And then people start to Google and search 3D printing houses, and then you will come up as a business because you are there. And because there isn't a lot of us, you'll get the business because somebody else built something somewhere else.
Yeah, and I think that's the big incentive for people to be early movers in the space. And even though you know the technology is under development, future models will come out. But if you're the company who is early to the game and is developing your employees' experience with the modeling and the printing, some of those things are going to carry on to the next iteration of the technology. And so you'll have a lead and an advantage in the market. And also the marketing value and the global interest in these projects, it's not going to be a novelty or a new thing forever. So the companies who join in 5 years, in 10 years, they're not going to be headlines on the news the same way the companies joining today are.
Yeah, so when we did, and you're dead right, because when we did the public demonstration in Hamilton, Hamilton Council sent a press release, and it was covered in the local newspaper, but then it got covered globally, and I found the article that was made in New Zealand, translated to Polish, translated to Dutch, and I was looking at it. I never thought that I would be in a website in Poland before. It was never on my radar. It's not that I don't want to, but I never thought about it. Yeah. So this is the kind of coverage that everyone benefits from. So if we're gaining coverage or gaining leads or getting, building awareness about the technology, it's better than we actually work together, because everyone's success helps other people. And a lot of some of the material suppliers that we talk to, they tell us they get approached by companies that are startups that didn't have a robot, don't have anything, and they want to dictate to them that I want to have exclusivity with you, and I'm the only one that will sell material to. And they look at them and say, who are you? You don't have anything to dictate any of these terms. And also the other thing is, the only way for us to make it mainstream and make it competitive commercially and pricing and drop the price down is we need to have scale. We need to have scale in ordering robots. We need to have scale of manufacturing robots. We need to have scale of logistics. We need to have scale in getting the raw material, whatever material that they're using. And the only way to get scale is to spread it as fast as possible and as much as possible. And to gain this traction, we cannot really reinvent the wheel every time someone's trying to do something new to their production line.
Yeah, I'm in kind of a unique position where I'm in touch with a lot of these companies and not in a competitive way at all. So none of them see me as a competitor. I feel like there should be some way that I could help facilitate that collaboration and interaction. But I don't know, where do you think I could start with that?
Well, I think the first thing to start is to approach them individually, because you interviewed pretty much every single CEO of a company that's worth knowing about so far, and you even made a video about it. So the biggest thing is to float the idea first with them and see how they're going to react and see if they're open to it or not. And then we can have like the what's called worldwide conference, like the one that Winson have done. What I'm saying is that have a big meeting somewhere, because we still cannot travel, and everyone's too busy to travel just for a specific conference that will take 1 or 2 hours. That could be done through a Zoom meeting or something. So, and talk to the people, talk to your contacts, see what they think, if it's worth it or not. And then after that, agenda needs to be developed to talk about it. And generally, even before the agenda, it just needs to be a theme of what we're trying to do, or the spirit, then the meeting spirit, or the meeting vibe, let's say. It's not about people bragging about who they're working with, or what projects that they have done, or what they have in the pipeline, or what. It's just about knowing each other and helping each other out and supporting each other.
Need is for the collaboration. Like, would it be most valuable for companies to share information about the 3D modeling they're doing, the softwares, the splicers, the material?
You can look at all of the components of what goes inside a 3D printer or a 3D printed house or a product. And then you have the raw material, you have the pumping system, you have the robot itself, you have the software that you use for controlling the robot, and the software that you use in the designing or slicing. You have all of these things, all of these aspects. Each company that printed a house, they have them, but they have done it in one way. I'm not saying that's the right way or the wrong way. It's one way. It worked. It worked for them. What I'm trying to say is that if a company on the side that see that they need improvement in one of these areas, and they see something they like that another company have done, to talk to this company and say, can we work together on this?
It's tricky because they all have different things that are important to them. Like a lot of them are very protective of their mixing system, and they don't really want me to film too much of the mixing system. CyBe is totally open to me filming parts of their mixing system and explaining the different aspects and me putting that on the internet. Whereas CyBe does not really share so much detail about their material ingredients, whereas other companies might be willing to share material ingredients, but they don't want to share the mixing thing. So it's tricky to find.
I understand, but and I totally get where everyone's coming from. I'm just saying is that hypothetically, you have a company that's developing a new type of product, a new type of robot that already a company has it. Yeah. It's there. Talk to each other instead of you developing it completely from scratch. Let's say hypothetically, a company that produces gantry systems or a company that produces robot. These guys want to produce gantry system. These guys want to produce robotic arm. Talk. You have a lot of experience in this area. You have a lot of experience in this area.
Maybe the 3D models are a good place to start because those are kind of like a dime a dozen, easier for companies to make a model and then have a system where it demonstrates like for this printer, the model is printed in this time with these methods.
Yeah, you're right. Maybe modeling and software, because at the end of the day, even companies are saying they're technology companies, but at the end of the day, they are construction companies. That they develop the software for the 3D printer. They don't develop the software for the sake of the software. So you can start with the modeling, and it's a very valid point, and also maybe splicing software, or robot, because the splicing, no matter what system you do, if you have a couple of parameters that you change, and you can be slicing the whole house or you're slicing a planter, it's the same approach.
Yeah, I think start small with one specific topic and then build from there. And then once the companies see how nice it is to work with each other, they'll build more trust and be willing to share more.
Yeah, exactly. And this is I just thinking about it now after speaking out loudly, it might be the best option, because then you gain you know the people, you gain perception about what they are and what kind of people they are, and you build a working relationship and trust between each other. And this could be the beginning of more collaboration in other areas that are more specific. And because, frankly speaking, the majority of the big material suppliers, they don't really care about who they're working with. So they will work with anyone. If I want to buy material tomorrow from any of the big guys, they will sell it. They don't care. Just they will not sign an exclusivity agreement with anyone, even though some of them actually own shares in other companies, like LafargeHolcim sells to Copod, sells to a lot of other companies. They just did a house in Malawi with a Copod robot, and they own shares in X3 in France. So this is how exclusive they are. They're selling products to their subsidiaries competition. So generally speaking, there's no exclusivity in the top, but they spend a lot of time and a lot of energy developing their own material. So you might be right. It's just baby steps. Build a relationship, build trust, and if you have this global collaboration meeting once a year or once every 6 months, and people get to know each other more, they get familiar. People might invite each other to come and visit their facilities, and this will also could be a beginning, as long as it's done on the high level, not pushed to construction managers or production managers or product managers, because it end up happening that these guys have this much workload in front of them, and they are not the decision makers, or they are scared of making a decision because it might be the wrong decision to collaborate with someone, and then they ended up being in the doghouse for releasing IP that they shouldn't.
Yeah, it needs to be easy too for the company so that they don't need to dedicate extra resources.
Exactly. And the whole idea is to actually reduce the the load on the resources that we have, because it's becoming very, what we're doing, because it's not mainstream. There's a lot of people that know it, and you have a very steep learning curve to understand how the technology works. Because builders or construction engineers or structural engineers or architects, they have no idea about robotics. They have no idea how 3D printing works. On the flip side, robotic guys have no idea about construction. So you're starting to have these hybrid people that know a little bit on the other side of the fence. And it's very unique, and there aren't that many of them around the world. So, and that's what I'm saying is that if they collaborate, so this team have done something, you have done something, you can work together. Because if you're trying to repeat what this guy have done over there, and you have very limited resources, because again, there aren't a lot of people, and we're talking about startup businesses that they cannot hire hundreds of people and they have a big R&D departments, you need to do the most with the resources that you have.
So since I guess we're kind of coming towards the end of the podcast, is there, if somebody's interested in working with you, working with Qorox, how should they contact you and get in touch to do a project with you?
So we have all of our contacts on our website and our social media platforms, and my name and my contacts are available online, on LinkedIn or through our website. They can call us, and we're based in Hamilton in New Zealand, which is an hour and a half south of Auckland, and it's central of the North Island, close to, it's the middle half of the North Island, let's say. And then we're servicing the area around us, because again, we're a startup, but we cannot afford to be everywhere. So we're not servicing the South Island of New Zealand, which has maybe around 20 to 25% of New Zealand population, mainly just because of logistics and only having one robot in the country. We're looking to grow and cover more area, but generally speaking, you can find us on any social media platform. We have a TikTok channel, we have a YouTube channel, we have Instagram, we have Facebook page, we have a LinkedIn page, and our website. The only thing that we're not on, we have a handle as Twitter, mainly because it's not really popular in New Zealand, so we're staying away from it for the time being.
Yeah. And are there any positions you're hiring for if people want to work for Qorox?
Currently, no. We use external, we outsource some of the stuff that we need help with. And also CyBe gives us a lot of support when we need to. The biggest thing is the busier we'll get, hopefully we'll be able to order our second and third robot, and then we will be looking for recruits. New Zealand immigration laws are quite difficult to get people from overseas. So predominantly we'll be looking locally to recruit, which helps us a little bit that the system is quite user-friendly and doesn't take a long time to learn it. So what's going to happen is that like these guys were trained in a month, we will be able to train someone else in a month. And hopefully by then the borders will be open so they can travel to the Netherlands and get the training with CyBe.
Great. And you mentioned you're looking into buying now a second and third printer?
Not immediately, but hopefully it all depends on how the next 6 months will go and how much traction we'll get on the market and how we can move forward from there.
Very nice. That's a good sign. So I'll make sure to link your website in the description of the video. And thank you very much for taking the time to speak with me today. I really appreciate it.
Yeah, well, thanks a lot. Have a good day.
Yeah, we'll be in touch.